Okay, so here we have our first sort of full-blooded, hard core 3 trig equation using the addition formulae. So part 1 is a routine thing, expand r times cos theta plus alpha. So this should be almost instant. We really must know the addition formulae for cos a plus b. So you get r times cos theta cos alpha minus sine theta sine alpha. Okay, so those formulae, really have to be very fluent with those. Right, so now we are told to choose suitable values of r and alpha and thereby solve this rather scary looking equation. And again, the reason it's scary is I've got two different trig functions, cosine and sine, both stubbornly there in the equation, and I really want to reduce it to just one trig function. So the aim is to use part 1, so to get r cos theta plus alpha to match up with the left-hand side in some way. So what would that involve? Well, I guess we want 3 cos thetas, and if you look at our answer to part 1, the number of cos thetas is r times cos alpha. So we get this equation. It would be wonderful if we could find r and alpha that satisfied r cos alpha equals 3, and also the number of sine thetas in our first answer is minus r sine alpha, and we hope that that would be minus root 3. So that says r sine alpha equals root 3. And now at this point you've kind of got two choices, and people do it very different ways. So one way is sort of heavy on the algebra. How can I solve these two equations? Well, you could divide the bottom equation by the top equation, and the r's would cancel, and that would be a way of getting rid of one of the variables, and you'd discover that sine alpha divided by cos alpha equals root 3 over 3. That's actually tan alpha is root 3 over 3. That's a famous one, so alpha would actually equal 30 degrees. And how do you find r? Well, two ways. You could substitute back in your value for alpha, but actually there's a slicker way, which is to square both equations and add them together. R squared cos squared alpha plus r squared sine squared alpha equals 9 plus 3. Why does that help? Well, the reason is you've actually got here r squared times cos squared plus sine squared. But whatever the value of alpha is, cos squared plus sine squared alpha is always equal to 1. So you get r squared equals 12. So r is root 12 straight away, and that should probably be simplified to 2 root 3. Okay? So there you have it, an algebraic way of solving the equations in green. You find the angle by dividing one equation by the other to discover tan alpha is root 3 over 3, and you find r by squaring the equations and adding them. Discover that r squared is equal to 12. And that always works for problems of this type. The other method to get exactly the same answers, I think I probably prefer, it's rather than being heavy on the algebra, heavy on the geometry. So what does r cos alpha equals 3 make us think of? Well, it should make us think of a right-angled triangle with hypotenuse equal to r, an angle alpha, then r cos alpha would be the adjacent side, and that would be 3, and r sine alpha would be the opposite side, and that should be root 3. So the equations in green automatically make us think of this red triangle, and our task is to find the angle and hypotenuse. So now it should be obvious that tan alpha is root 3 over 3, because it's the definition of tan, opposite over adjacent, and it should also be obvious that r squared equals 3 plus 9, so r equals root 12, because that's just Pythagoras. So those two approaches are morally similar, but it depends whether you're more comfortable with the algebra or the geometry. Okay, so now we're in good shape. We've managed to reduce our problem to the following equation, which is much less terrifying. It says 2 root 3, that's r, root 12, cos of theta plus alpha was 30 degrees is equal to root 6. And now I can make a single trig equation subject. Cos theta plus 30 equals, okay, so it's root 6 over 2 root 3 Okay, we can simplify that in a second. So it turns out root 6 is actually root 2 times root 3. But before that simplification, I'll do my standard simplification. Let stickman equal theta plus 30. The reason I do that is because I still have the same range, theta between 0 and 360, so I now get cos of stickman equals root 2 over 2 is how that simplifies for, and I must adjust the range, so stickman is 30 more than theta, 30 less than or equal to stickman less than 390 degrees. Okay, now inverse cos of root 2 over 2 we should know. If we don't know, our calculator will remind us that stickman is equal to 45 degrees as one solution, and then either thinking about the graph of the cosine function or thinking about x-coordinates of points on the unit circle, or using the rule do 360 minus, we get all stickman equals 315 degrees. So, how's that related to theta? Well, theta is stickman minus 30. So our final answer to this problem is theta equals 15 degrees, or 285 degrees. And those are the two final answers and the only two in the given range.